Start streaming. And let's double check and make sure we're actually streaming. We're actually streaming. Sick.
Now stream in Discord.
And now I need to open this. Go to YouTube. And get my stream link.
Also, did you see the Reddit post of someone who's definitely struggling in OS right now?
No.
It's kind of hilarious. Like, it's kind of true, but also kind of hilarious.
The one about 203?
203 OS, yes, that one.
Yeah, I saw that. It kind of makes me scared.
Okay, right. Stream Q&A, we're going to go ahead and post the link there. And then we're also going to post it in Instructor General for later use. And then I need to go here, and I need to click on... Are you streaming, Chris?
I forget, do I need to... Oh, right, I am. I
stream to Discord.
Right, yeah, hold on, let me get the... I couldn't remember if you had the PowerPoints or if I did. So now I will.
Yeah. Although, if are you going to be hopping back between your VM and the PowerPoint, or are you just doing that for the end?
So let me check real quick.
Because if you're going to be hopping back and forth, I'll do the presentation, and then you can just pop your stream up. That way you don't have to drop one and then bring it back if you're going back and forth.
So let me see. I should be able to do... Thank you, Discord, for not letting me do a singular screen. Okay. So I will just... I'll just switch windows in Discord, and it should just... I shouldn't have to stop streaming to switch.
All right, cool. Go ahead and stream, and let's give it a quick test.
There we go. Okay, so that's
all right. Now switch.
So then, change windows.
Bingo, easy peasy. All right.
Okay, cool. Okay.
Cool. I need to bring your Discord down to this particular workspace. I love workspaces, by the way. If you guys are on Windows and have never used Workspace, you literally, well, at least on GNOME desktop, you can flick the corner of your screen, and you have multiple desktops. And you just kind of click on one, and it has different windows open in it. It's great. It means it's easy for me to get way too many things open at the same time. It's a good thing I have a 12-core, though.
Yeah, I always end up switching back to something in one desktop or another. I never have a good way to split them.
Yeah, I got an extension that allows me to have multiple open.
Okay, so are we ready? We can get started.
Yeah.
Okay, cool. So welcome, then, like 10 or so of you, to the second Linux PowerPoint. Basically just going to be continuing from last time to go a bit more in depth. Most of what the PowerPoint I got into was permissions, like really in depth with permission stuff, just because we never really went over them. We didn't go over them last time, and that was kind of an accident. And they were only mentioned in the first Linux PowerPoint during the semester, so and they're good to know. So we're going to go over that, and then going to go over some whole bunch of commands. I'm just going to demo a bunch of stuff and kind of give some use cases. And then just briefly mention package managers, because those are a thing. So yeah, it's basically what I just said. Permissions. So these are all of the different flags you're going to see on a file or directory for given permissions. Here's what they stand for. Read is largely obvious. Write is also largely obvious. Execute for files is again, kind of obvious. Search for directories is not very obvious. And then the set user ID and set group ID and sticky bits are probably not at all obvious. And again, they kind of behave differently depending on whether it's a file or a folder. So we're going to go over that. And then I'll kind of demo any of this later, just to reiterate, or if anyone specifically has questions. But just so I don't screw up the demos, because we all know how live demos go, I did all this ahead of time. So read permission. Files, you can read the file. It's so basically the format of most of these images is I first do stat on the file, which gives you a bunch of information about the size, the file system inode, the links, when it was modified, what its permissions are. So the main thing that you look at in the stat output is where it says access. It's the fourth line down. And right next to that, it has numbers and then a bunch of dashes. The numbers are just the octal representation of the permissions. And to the right of that is the letters, which were mentioned on this previous slide. So for demo here, I have a file called hello.txt, and it's just a regular text file. And the permissions are, do I have a laser pointer? I do. And the permissions are read and write, which write is the octal 2, read is the octal 4, and the combination is 6, which was kind of mentioned in the Linux 1 slide. So then I just print the file so you can see I can in fact read it. And then I use chmod, which is change mod. I actually don't remember what exactly it stands for. Basically, change mode. That's what it is. So, and then you tell it what you want to set the permissions to. In this case, I'm saying I'm going to modify the existing ones. So I'm saying user, which is the first block of permissions. I want to subtract the read bit from the users. So I'm effectively going to do standard grade school subtraction and just take away the R from the user section from this. So I should no longer have read, and then kind of to show that what it actually did, it does in fact take away the R. So now I can't read it. And then I go away, a little pop-up thing. And then down here, I try to read it, and obviously I get permission denied because I can't read it. So that's fairly straightforward as far as what you might expect. Directories, read and execute are a bit weird in this, and you'll see why in a little bit. So same thing as before. I stat this so you can see what the initial permissions are. The D up here is just saying it's a directory. Read, write, execute. The execute is basically going to be on every directory, and you'll see why later. And then read and write kind of for the same reason. So ls tests, the directory is named test, and there's where the hello.txt file is. So then I get rid of the read bit on tests, just verifying it's done that. And then if I try and list it, I can no longer see the files inside of the test directory. And then not in the screenshot, but a side note is you can still cd the change directory into the test folder because of this execute bit. You still can't read anything in there, but you can move into it. And then here's a follow-up on read. It does not prevent you from reading files inside of that which you can already read. So from the previous setup, test has got the read, write, execute. Hello file is here. I show you that I do have read permissions on this file. So like last time, if I were to cat the file, it would say hello world. If I remove this read permission from the directory like last time, I can't see what's in it. But if I try and cat the file, it can read it. So this is just kind of a thing to be aware of, is the read permission does not prevent you from being able to access the files inside of it. It just means that you can't see what files are inside of it. So it's I guess kind of like a secret mailbox of if you ask me what's in there, I won't tell you. But if you say I want to get this specific one and you give me some unique identifier for it, I will give it to you because you already know about it. That's, I guess, an analogy. So then write. So for files, fairly self-explanatory. Stat hello, it's read write. Print it out. I can append to it, which is what this is. I print it out again, and I've now appended to it. You can see that. So this wasn't consistent here, but chmod 400 is just saying set it to 400, which is read only. And so then I show again, it's in fact read only. And then if I try to do the same command as before, I get permission denied. I can't like modify it in any way. I can, however, delete it, though it'll give me this warning about write protectedness, which if it does have write, then it'll just delete it without any qualms. So that is write. It's like write, append, modify. It's all same thing. So then for directory, it's similar. So for directory, it's that you can't create files. So you can read, write, execute. So I create this new file called new file, and you can see it in here along with the old one. Then I change the directory to 500, which is write and execute only. Or sorry, read and execute only. And then try to create another new file. It obviously blocks me. But I can write to this new file which already exists. So I can still write to stuff inside of it. And then if I try to delete this new file, I can't, because that is under the the write permission, is being able to delete stuff. And I believe it's mostly that way. So then execute is, for binaries, most files are not executable just because they're not executables. So for those that are, it says whether or not you can actually like interpret it as what it's supposed to be. So this is just a bash shell file with all three permissions. Then I just show you what's in it. It's just going to print hello world. I run it. It does print hello world. And then I remove the execute bit by doing 600. I didn't show the permission, but it just gets rid of the X. And then I try and run it again, and I get permission denied, which is because I can't execute it. I guess just quick side note is, even though I'm the owner of the file, like in all of these cases, I can obviously modify the like permissions of it, but if their permissions aren't set correctly, it'll still deny you your own files, just because of how the permission system is set up. So, but because you're the owner, you can change it. So like it doesn't actually mean anything. It's just how the system security works. So for directories, kind of in the beginning, what I mentioned was it's called search instead of execute for directories, and it's because so basically what I believe the setup is for like read versus execute is in like a file system, like data structure tree or whatever, you've got some folder and it's got a list of all the files in it. And if you have read permission on that particular folder, you can like you can get that list of files. Or sorry, take that back. Actually, no, I don't know where I was going with that analogy. Let me just stick to this. So the directory test has all three permissions as before. I can cd into it. I can list it. You can see hello.txt. Go back out. I remove the execute bit. Show you that I've removed it. And then I can't cd back into it. And I list it. And I get two kind of conflicting things. It says it can't access this file. It's telling me what the file is. And then it prints the file here. So and then I try and print the file here. So the reason for this kind of weird conflicting information is because the ls command, at least how I have it aliased to, tries to color files based on what their type is. So it kind of makes it easy to figure out at a quick glance which files are what type, like what things are directories, what things are executables, that sort of thing. And so kind of in order to do that, I'm getting the impression that it tries to like open the file and get information about it. And so that's kind of what this permission denied is, because it's trying to open these files and it can't access the like the file node itself, like the file system node of it. But because we have read access on the directory I guess has like an inherent list that, because you can access the directory like object, you can access the list of the files in it, but you can't actually access the like node of those files. Are there any questions so far? Because I think I've been going somewhat quickly. Okay, nope, that's Richard. All right. If there are no questions, then I will continue. So, there we go. So, those were kind of the three permissions you'll see like 80% of the time. The other little bit is these weird things called set UID and set GID, which is set user ID and set group ID. And basically what they do is they set the effective user ID and group ID of the like process to the owner of the file. And the difference between like effective user or group and just the normal user or group is the user and group typically don't change. It's typically like who you're logged in as. And the effective is like, who are you acting as? And kind of in my testing and from what I could tell, even though it sounds like this works for any user, is from what I can tell, it basically only actually works if the owner is root. Otherwise, it just doesn't work, and it's because how the like kernel security works is that the set UID, set GID like system calls pretty much you can only actually change users if you are root, which is, I guess, just kind of an inherent restriction of them. Hence why it basically only works when it's root, even though it kind of implies it would work otherwise. One common example is ping, which technically needs root not technically, it does need root access for being able to access some network stuff, to, I guess, be able to craft whatever packets it needs to send out. And instead of having to, so some systems have it to where you do need to like sudo or su in order to run ping. Others have it so that they have the su ID bit set on ping, which means that when you run ping, it runs it as root. So that way you can just run it and you don't have to, you don't necessarily have to have admin access like to sudo or su, and it'll just take care of that. The kind of modern solution is a thing called capabilities, which I'll kind of briefly go over or briefly mention in a few slides, that kind of achieves the same thing but is less potent than giving full root access. Okay, so then that was kind of all for files. For directories, it's a bit different. The set user ID bit has no effect as far as I can tell. I can't find anything on it. The documentation on set user ID doesn't seem to mention directories at all. The group ID, however, is if you create a new file, then the set group ID bit on the parent directory will make any new files inherit the group of the directory. So in the demo over here, I've got my test directory as before. It's world readable writable, because I'm going to be using a second user here. So test is here. So it's world read writable. It's owned by my primary user Chris, and then my primary group is Chris, and I am currently running as the user utility, which is just a second user I set up on my computer. And so I'm going to, and the set GID bit is not set. You would see an S in this second X position here, and you would also see a 2 in this front position. So I create this new file as this user utility, called a util file to keep it easy to figure out. And then I look at the permissions of the file, and I can see that the utility user owns it kind of naturally. And the group ID is users. That's just the primary group of this utility user. It doesn't have its own group like I do. So fine and dandy. So then I log out of the utility user so I can actually change its directory, because my Chris owns it, not utility, so I can't do chmod on it without being Chris. So I change it to 2777, which is basically the same it was before up here, except that 2, which will give it the the set group ID bit. So then I change that. I log back in as utility user with the su command, and I'll kind of demo and go over that later. Create a new file, util file 2, look at it. Same permissions as before, owned by me, except now the group ID is Chris, because of the set group ID bit, and the file being owned, having the primary group as Chris as my group, then this user, even though it creates a file in here, it is now part of my group. So and then what was this next one? Okay, that's sticky bit. Okay, yeah, so that's set group ID bit for directories. So then sticky bit, the last and final one, is actually one you'll see typically on the /temp folder, which is just a system temporary folder that programs can use. It's typically erased on boot, and at least on my computer, it's a RAM disk, so everything is deleted on reboot anyhow. So same starting point as before, world read writable. Then I will set the sticky bit on the directory, which puts this T in this last position here, and puts this 1 at the beginning. Otherwise, nothing else changes. So then I'm going to echo it's me, this text into this new file, Chris file, log into the utility user, do another file from there. You can see all the files are in here. Going to, as the utility, try and delete the file that I created as the Chris user. It's write protected, so it's not going to be able to do anything. And then I say yes, and then I get a permission denied because I do not. The utility user does not own the file. So then I log out, and then as my Chris user, I try and remove the utility file, which Chris doesn't also own either. It gives me the same write protected prompt, but when I hit yes, it does it. It doesn't give me any permission denied. And I list it, and you can see it's not there. So the sticky bit basically prevents it. It restricts deletion to root, directory owner, and file owner. Root's kind of implied. Root can do whatever they want. File owner is also kind of implied. If you own the file, you can do whatever you want with it. And then the only thing that really changes is directory owner. So kind of as I showed here, it's if some other user creates a file, then I don't own the file, but because they created it in a folder, which I do own, I can delete it. So I guess that could be useful for shared folders if you're to, I guess, not have a, yeah, I guess you could do share folder type setup. So now ACLs, or access control lists, they're kind of closer to, I think, the Windows permissions and what you'd probably see if you ever dig into the settings of your file, the properties of your file, and look in the permission settings of it, you'll see a bunch of names and groups and stuff, and this is closer to what that is. So it's extended file attribute information specific to each individual file that can let you give specific user groups read, write, or execute permission, and like only for that file. So the standard model is user group other or world. So instead of, if you want to give, I don't know, if user Bob wants to give Jane permission, you can give it specifically to her without having to give it to everyone by like opening the world write or read. So it works for files and directories. And directories can have a default, which any files that are created inside of it, any new files can just inherit it. So it makes, shared stuff easy if you just want to say, by default, anything in this folder will be accessible to this person or this group. Anything newly created will just be automatically accessible. So then I didn't really want to go too in detail of this. I didn't get time to demo all of this, but actually I might have. So you read the current ACL with get FACL, which is get file ACL. And you just give it the file name and it'll print it. I have an image on the next slide of that. And then to add or modify, you do this M, which is modify, or for set file ACL modify. And then you give it user is U, group is G, and then I don't have it on here, but mask is M. Then you give it, username, group name, and then permissions, in this case read write, in this case read execute, any combination of the three. And then you give it the file. You might be able to specify more, I don't recall. And then I just explain what I just said. And then the X removes entries. So, and it doesn't have these permission bits at the end. So, because it doesn't really matter if you want to change them. You would just do modify and set them. So X just removes the entries. So if we did user Dave read write and then just did X user Dave, I forgot to put the file at the end here. It would just remove Dave from the ACL and he could no longer access that. And then the last one is the -B, which just removes all the ACL entries except the base one. So by default, if you just run this get FACL on a file that you haven't ever touched with ACLs, it's going to have basically the default permissions that you would see with the stat command in the previous couple images, with just it'll have some comments for the user, the owning user, owning group, and then the user group other permissions. And then once you add this, it'll add this line, it'll add a mask line and a few other comments. So this is an example of the default entry. You see file is just saying what it is. Owner, it's saying I own it, because this is my home directory. Group is also mine. And then these are just the default user group, other, and read, write, execute. So that's the base stuff. And then here, I want to say give the user utility read and execute permissions on this dot, which is directory. So I want them to be able to basically look into this directory. I didn't demo that they could, but trust me on this one, it'll just work. And then get FCL to kind of show you that it changed. So now, in addition to the default user group and other, you've got this user line with utility, and this mask line. So this line naturally is the one we added. This mask line is added, and it's basically determines the effective permissions of everything in here, or of everyone in here except the owner. So if I had a dozen different users in here with some combination of read, write, execute, and this mask was read, write, execute, then everyone would get whatever I gave them. if I change it to read execute, then everyone on this list will only get read and execute because the masks for like security is typically a bitwise and, which means both things need to have it. So if some user has write and the mask doesn't, the user won't get write. So this basically, so if I were to, and I should have shown this, but if I were to have given the utility this read write execute and I changed the mask to read execute, you would see the read write execute here, and there'd be a comment on the side that would says effective read execute. And it's basically trying to pull attention to the fact that I've given them more, but because of the mask, they don't actually have that. And I can demo it to show you what I mean in a little bit. Capabilities. So these are the thing I kind of alluded to a little while ago, which are like the set user ID bit for execution, except they're a bit more specific. About 40 sub capabilities to be specific. So what they do is they are properties of a processor or file which grants some permissions that they need without giving them full root. There is one or two capabilities that are basically equivalent to giving someone root. Ignoring those 2 or 3, the rest of them are not like equivalent to giving full root and are much safer. So back to the, and I can show this as a demo as well. There's a specific capability for the thing that the ping command uses, and like I said, modern versions have this capability instead of set UID. So the executable ping has enough power, if you will, to do what it needs, but it's not full root. So if someone somehow exploits the ping command, it'll be a lot harder to get anywhere with it because it's got a much more restrictive subset of permissions that it can actually do. And it's still kind of, the capabilities are still relatively new. So some things don't have like interoperability with it. But basically the commands similar to the ACL are setcap and getcap, used to modify and set and read the current file capabilities. And I was just saying, if you care for more, and I can briefly scroll through this to show you how big it is. This contains oodles of details on like how capabilities work, what capabilities there are, what they do. It is quite detailed. So then these are a bunch of commands. I'm going to skip this for the moment and come back because I'm just going to probably start by demoing a bunch of these. So this is the package manager thing that I was talked about. Basically, every distro is going to have a package manager, unless you're someone who does Linux from scratch, which is building your own like distribution OS, basically. Basically like an app store, closer to like a Git repository. It has things called packages instead of apps because unlike apps, like they can be a full like desktop app, but it's usually just a collection of libraries or other stuff of that nature. And I just said precompiled here because unlike like a Git, it's most things are just binaries that you download and install. Though there are a few like the Gen 2 distribution, everything is source. Like you download everything in source and you compile everything to install it, which is kind of the odd one out in most of these. The repositories are typically have categories for what the packages are for, either based on the source or the importance to the distribution. So source being like an Ubuntu repository, if you've ever seen Ubuntu tutorials, they'll be like, add this repository before you install this package I made. And it's like ppe:// and then whatever URL. So that's like a custom repository. And then the built-in ones would be like Debian's got like a stable branch or an unstable branch or a security branch type thing. So that's what those are for. And then just briefly mention the distro dependencies. So Debian and its derivatives have the base Debian package. dpkg is the command for that. More commonly, you'll see app or aptitude. So if you've ever done Ubuntu or Kali, I believe, is Debian based. So you'd see to install anything in Kali, it'd be apt get install stuff. So this one you'll probably run into more often than not, just because Debian derivatives there's many of them. Red Hat and derivatives, so like CentOS, Fedora. I think OpenSUSE is that possibly, or OpenSUSE uses the RPM, but so they use Yum or DNF, which I looked up earlier is Dandified Yum. It's basically an upgraded version of this. So that's that, and then just because this is the third one I could find, Arch uses Pacman, which I think is probably the best named one. I'm not biased at all. But so these are kind of the main three I could find. Then the fourth one I think would be Gentoo, which is like the source code thing I mentioned. But not super important. Just figure out which one you use and get to know it. They're not terribly difficult to learn. And then that's the end of the PowerPoint. So I'll just briefly explain some of these commands, and then I'll kind of go through and demo a few things. So stat is the one that you saw throughout a bunch of the pictures. It just gets you information about the file. Like I said, the modification times, access times, permissions, users, like file system information, that sort of thing. Find is basically your file search in the terminal. It's got all kinds of things you can search for. You can search by name, you can search by type, you can search by size, you can search by like permissions. It's got a absolute like massive amount of options you can use to look for files. So if you need to find something, go to find. It's that. File. This one is kind of it tells you what a file is, like what type it is. So if you do file, like in the file I had through the examples was called hello.txt. If I just did file hello.txt, it would say ASCII text file. And it basically just analyzes the first couple bytes of a file to figure out what it is. Since most files have some sort of identifiable information in the front, so you know what it is. Like JPEG files, in the first, I think it's like the second through fourth bytes or first through fourth, I don't remember, have the four letters JFIF, which is an acronym for whatever foundation made the JPEG standard. So, and most like binary formats have ASCII letters at the front, so that if you're opening a file in a text editor or a hex editor, you can read what type of file it is without having to like convert binary numbers. So file just tells you what stuff is. Sed is short for stream editor. It basically allows you to edit files, and it's kind of like a line-by-line editor. So if you pipe stuff into this, you can replace characters, you can replace strings, you can do a lot of fancy tricks with string manipulation. TR is translate. This one you probably won't use too much. It can be used if you want to strip like new lines out of strings or ASCII. It'll do that. You can have it convert between two alphabets, for lack of a better term, like two sets of characters. So as I learned the other day on the Bandit over the wire thing, you can use translate to do the rotation 13 cipher. I guess rotation any cipher, you just have to kind of flip around what order. This one, yeah, so it's interesting. I'm just mentioning it. Tar is tarball. It's basically the Linux archives, kind of like zip files on Windows. You can also get zip on Linux. It's just called zip and unzip. So this is, you'll see tar.gz files or tar.xz or something. The tar is just an archive, and then the dot whatever is typically compression added on. SU and sudo. Sudo has kind of been mentioned before in a variety of the things we've done in the Kali VM. It elevates you to root privileges, and it authenticates you based on your user password. So if, in my case, if I was user Chris and I say I want to sudo into root, it'll ask me for my password. Su is kind of an older version, and it's just substitute user. And in some of the demos where I was logging into the utility user I created, when you do su user, it asks for that user's password. It's slightly it's not really configurable at all. It's pretty much like logging out and logging into a new user, except you don't have to log out. You just do it in your existing terminal. So typically it's recommended to use sudo. So yeah, there's that. ID and groups give you information about your current user, or any user for that matter. ID kind of can tell you your user ID, your name. It can give you the group IDs you're in, the group names, that sort of thing. Groups is more just about what groups you're in, the IDs and stuff of them, that kind of thing. Push, depop, and dirs. These are not really commands. These are shell built-ins. But they're super useful for workflow because they manipulate a directory stack. And for instance, if I'm in my home directory and I want to temporarily go to the temp folder, I could say push directory /tmp, and it will change directory. It'll basically cd me into the temp folder, and it will push my home folder, basically where I started from, onto the directory stack. And then the dirs command here prints out what the stack is. And you can do this multiple times, and basically every time you do push and give it a directory, you change into the new directory and push the directory you're in onto the stack. And then popd, it's kind of the opposite of that. When you popd, it changes directory into the top directory on the stack. So super useful for going places and going back without having to type in cd and then the full directory name. So it's super convenient for that. And also, you can typically reference stuff on the directory. So if you have, say, 3 things on the stack, you can copy a file from like one to the other by just doing a little tilde and then like 1, 2, or 3, which will reference 1, 2, or 3 in the stack. So it basically gives you a shorthand for typing lots of a full path out. So for copying stuff, super useful. So I can demonstrate that a little bit as well. WC is word count. It just does kind of some file statistics. Typically, you'll do word count tac L, which is saying count lines, and then it'll give you how many lines are in a file. That's usually what you'll use it for. That's mostly what I use it for. So that's just a nice utility. Diff is a file difference utility. You give it 2 files, and it will tell you what's different between them, unsurprisingly. If you've ever used git, then if you do like git diff or in a git commit, it will, if you look through a commit, it'll show you what changed in a file. And the format is basically the same format that diff uses. And you can have like side-by-side comparisons and that sort of thing. It's a useful thing. Awk here is kind of like sed. It's for string manipulation and stuff. Awk is like a whole scripting language on its own. Super useful for some things. I don't really want to go too in depth with that because I think there's already a lot here, and like I said, there's a small learning curve to awk, but it's super cool if you get to use it. Compare is a simplified version of diff. If you do compare file 1 and 2, it'll just tell you if they're different. It doesn't tell you how they're different. It doesn't tell you why they're different. It just says they are or are not different. So simple as that. df here is, do not recall what it stands for at this moment, but what it does is it reports disk statistics, like hard disk statistics, and it'll tell you how much space is used in your partition, how much is left, the file system type, where it's mounted, that sort of thing. Similarly, DU stands for disk usage, and this tells you information about files on the disk. So if you want to find out the size of a file, like the physical size of a file, not necessarily the actual size, like the size on disk, this will tell you what that is. And yeah, so that's just that. W and who are kind of commands to tell you who is logged in, what users are logged in. W typically has more information, like when they logged in, where they're logged in from, what command they're running, CPU time, some other stuff, and some system information, like how long your system's been running, how many users are currently logged on, that sort of stuff. So these are kind of useful system awareness things. This star sum is just a collection of checksum things. And so one of them would be like SHA-256 sum, and then a file or a string. Just figure out what the SHA-256 of that is. SHA-512, 384, MD5. There's a whole collection of like hash sum executables that you can do. I just kind of want to mention those. And then because I started running out of ideas, BC is just a calculator in the terminal. It's arbitrary precision too, so you can do really, really large numbers. It just might take forever. You can also do really, really small decimals. So this is your terminal calculator. It's probably better than, it's equivalent in some degree to your graphing calculator, but better in some ways, worse in others. So that's that. Factor is just, it factors numbers. I don't know how often you need to do that, but it's a nice program. Strings, I think, was mentioned in one of the assignments or labs, or PowerPoints or labs, and it just searches a file and looks for printable strings. Typically, you use this on a binary file to get like string literals or libraries, something like that. It's kind of used in reversing or exploiting, or ponables, I guess is the term. And then kill on here I just threw is for sending signals to processes, the default being sig term, I believe. You can tell it what to send, but usually it's just for stopping processes, but it generically sends a signal to a process. So I think that's all of those. And now I'm going to jump over to my Kali VM. Oops. And then demo some of that, some of these. Go live. Cyber, and then is it capital scored fish or lowercase?
The C isn't capitalized in Active Cyber.
Oh, that would be it. Forgot case sensitivity. Thank you. So, whoops. Why did that go tiny? Settings, display. Please be bigger. Which one? That works. Okay, oops. There we go. Is this readable enough for people?
Yep.
Okay, cool. I guess before I do anything, is there any questions of either the command stuff or just anything I've gone over so far? Am I going too fast, or is everything going all right, basically?
So I had a quick question about the read, write, execute numbers, like with I think 4, 6, 1, those sort of things.
Yeah.
I saw a lot of the number 7, and that doesn't quite make sense to me since that requires 4, I guess, zeros or ones to represent it instead of 3.
So it's 4, 2, and 1 is what 7 is. So actually, I'm going to... Does this give more information? This kind of does, actually. So man pages, if you don't remember, throw a number in here. So this is the 1, which is just commands. If I do 2, it's the like C functions. These can sometimes actually give you more information, like here. So here, change mod, changes files, mode, bits, whatever. The mode is specified in the following, which is a bit mask or everything here. And here are all the numbers of everything. So you can see here, user, read, write, and execute is 4, 2, and 1, just in this particular column. So like 7 is just 4 plus 2 plus 1, or it's 4 plus 2 plus 1, which is just saying they have everything. They have the read, write, and execute. And then similar thing with group and other, they're just these separate columns. And then the other column up here is the set user ID, set group ID, and then sticky bit. So that's what these are. They're just addition of these numbers, basically. So execute only is 1, 2 is write only, 3 is write and execute, 4 is read, 5 is read and execute, 6 is read and write, 7 is read, write, execute.
Mm-hmm.
It's just
so what would
that.
all the other zeros be used in, like the set user ID and group ID? I guess commands or values.
So these are all, if you notice, these are all in a column. So the front 0, I think, is just saying that it's octal, which is so like hexadecimal has a leading X, octal is just a 0. So you can see 4, 2, and 1 are in this column, this second digit, and then it's 0 all the way down. So this column is dedicated to these 3. Then the next column is 0 up here, and then the user gets the column in these 3, and then it's 0. So basically, each digit represents like this group, this group, this group, or this group of permissions. So that's what each number is for, is just saying, what are you modifying? You're modifying like the specialty bits, the user bit, the group bit, or the other bit, or digit, rather.
I see. Where would we use a number like 6 here, which would just allow all permissions?
So 6 is common because it's read and write. What you might typically see in a file is, okay, so these are all going to be, so this is going to be 7 and then 6, 6, or sorry, 755. 755 is kind of typical of directories. And then for files, I don't actually know if I have that many files in existence. I do not. Files are typically 644, which is read and write on the owner, and then everyone else can read. So 6 is quite common for files, if that helps.
Yeah, it does. Thanks.
Okay. So just to kind of briefly go down the list of things. So stat, as I said, gives you information, name, the size of the file. Directories are just 4K, because I guess that's just a disk block size. Device here, I think, is telling you where it is. I'm not entirely sure what that is. Blocks is just disk blocks. This is kind of file system level stuff. All right here. This is all the permission stuff, and then these are attributes. So you can see that it's accessed at 8:10, 37 seconds on 9/22, which is today. Whenever I statted this file. Modified, it was modified on the 9th, which is when I created the VM. Or, sorry, when this was installed by RJ, because this shouldn't change depending on when you installed. And then birth, most file systems don't record. Birth would be when the file was created. Most things don't track this, but it can. So for find, I'll demonstrate find. Find, if I so you give it a file and then flags and stuff. If I just do dot, it just goes through and finds absolutely everything. So if I wanted to be specific, I could do find dot. I could say, give me only directories, which is D. Now, everything here, you can see nothing has an extension. Everything is just its name, so it's a directory. I could say, find me all symbolic links. Those are all links. Do files similarly. I could say, give me a file that has its name, quotes just for why not. Star is wildcard anything dot png. It'll now find me only files with png in the name. Let's see, I think user, if Apache 2 is a user. Oops. Okay, that's going to be everything. Find us, you can specify a lot of stuff. File, this is the more interesting one. So I do bin, symbolic link to user bin. And the LSL kind of tells you this stuff as well. It's linked to user bin, lib is linked to user lib, etc., etc. So, and then if I do something like file bin / ping, it tells me some stuff. It's an ELF 64-bit shared object file. Basically, it's an executable is what it is. Dynamically linked, build ID, a bunch of other stuff. And kind of similarly, it's for most files you'll do it. It's that. And then if I were to do that, it's just empty. I do that and then run it again. It's now saying it's ASCII text. So file is super nice. Said the stream editor. Let's find a good demo for this. So PS, the command that gives you all the processes, prints everything out. You can see that it's got a bunch of space and everything just because it's nice formatting. There's another command called cut. And what I'm about to do, I have no idea if there's a better way to do it. This is just the way I've tried. Cut basically says, give me, if you do D, it says for some delimiter. So in this case, I could do space and then F for field number. If I say 1, it'll give me the first field when delimiting by spaces. So this should give me the user of PS, which it does. If I do 2, it's going to be a space because there's lots of spaces. So one thing you can do is you can do stream editor and then you give it kind of a instructions. S is this replace, and you give it thing to what you want to find, what you want to replace it with, and then this G just says do it multiple times in a line. When I do spaces, I'll do space, space star, which is one space followed by 0 or more spaces. And I just want to replace that with one space. So take any amount of spaces and put one space in it. And now everything from PS is separated by a single space only. So now if I do the same cut thing as earlier, I get the name as 1, 2 gives me the next, 3 gives me the next, oops, 4 is next, and now I don't have to worry about like uneven columns lengths and stuff. So that's kind of what set is. It's string editing. TR, don't want to go through all these. Okay, sudo. So I believe this user should have admin privileges. It does. Yeah, so sudo does that. It lets you execute stuff as root. SU in this case just changes. So the SU command, like I said, it lets you log in as another user. If you're already, so by default, it tries to log in as root. And because of how the Linux login authentication works, if you're already root, logging into something, it just accepts you automatically. There's no password asking because you're root. That's just how you can change that, but by default, it never asks. So that's that. So actually, if I were to do, let's just set the root password. I'm going to make it tor root in reverse. If I were to do su, it's going to ask for a password. And if I give it the tor password that I gave it, it logs me in as root. So it asks for the user logging in as. There's no more users on here, otherwise I'd show another one. ID command gives you your groups and gives their names. So that's useful. Groups basically does the same thing, except it's just the names. So I can access CD-ROM, floppy disk, sudo, because I can do sudo, and a bunch of other stuff. The directory stuff, this is the more useful things. So pushd, if I do pushd temp, that tells me what the stack is. So it's saying that at the bottom of the stack is my home directory and my current position is temp. I can change that, so I can go somewhere else and then do the dirs to print. So my home directory is on the stack. This top one is where I currently am. That can change just based on wherever I go. So then if I do this again, the stack is now this and temp with bin. And you can keep doing this indefinitely. So let me just do one more. So now that's the stack. So then, when I said you can reference the stack with something like tilde 1 or 2 or 3. So if I just do echo tilde 1, it's going to give me bin, because I guess it's the next thing on the stack. So 0 is where you are, 1 is where you go next. 2 is temp, 3 is that, 4 doesn't exist. So then I could say like ls that 3, which is 0, 1, 2, 3, which should list the home directory. And it does, equivalent to just doing that. So then I can do popd, and I am now in the user bin folder because that was what's on the stack. I can do it again. I'm in temp again. And then I can do once more going home. And then if I try and do it again, it just says the directory stack is empty. So that can be very useful for like productivity type stuff. Word count. Okay. So word count test.txt. 113. Actually, don't remember what all of those are. New line, word, and byte count. Okay, so this file has got one new line, so one line, one word, hi, and 3 bytes. So it's got the hi, and then it's got the new line, character at the end, which is why the prompt is here. So then I could just do lines for that. It'll just give me one. A more interesting demonstration would be, oh, right. User share. User share has lots of stuff in it. Dictionary, American English. And the American English Dictionary has 102,000 words in it. And I can just what's the... Oh, it's that. Oh, crap, it didn't work. Whatever. So it's just got a bunch of dictionary words. So your word count, you just typically use the count lines. Diff is a file, so if I do that, and then diff tests, and then test2, it'll say, starting on line 1, column 1, the file on the left, this file has hi, and then the file on the right has hello world. It's like I said, just simple difference between two files. The awk command I'm not really going to go over just because it's kind of a whole language on its own. I guess I can do a simple demo that doesn't really show much, but you typically have these programs in brackets. You've got like some like search rule here, or the special keywords begin and end, which run once in the beginning or end. The simple one is just print 0, which is print the entire argument, and then I'll just give it the dictionary file that I have been messing with, and it just prints a bunch of lines. That doesn't even look English. So yeah, just got a bunch of stuff in there. Could probably do a simple rule like start the line with a Y, and now it'll just give me all the lines that start with the letter Y. It's a whole language on its own, can be really useful. So there's that. Compare file, like I said, for diff is just, it just tells you the two files are different at this byte. So I think it just goes byte by byte, and as soon as it sees difference, it just stops. So it doesn't really tell you what's wrong. It just says that or doesn't tell you what's different. It just says something is different. The F command was disk information. Typically, I pass it this T flag, which gives me the type, like the file system type. And then if you give it H, it makes these more easily readable sizes. So it just kind of tells you the file system, the size, used, available, percentage, where it's mounted. So we can see the root partition here is 23 gigs. I've used 13, which is 40, or used 8.7. I have 13, and it's my root. So useful for, disk usage. Contrary, the disk usage command tells you the size of files. In this case, it just gave me everything. And then like the df, H gives you sizes. So in this case, most things are small because they're directories. This file is a bunch of kilobytes. You can just do HS, which just gives me the sum of everything in this directory, 1.2 megabytes. Or I could just give it a specific file and it does just that. So that's kind of useful as well. The W command gives you information: who, on what, from where, when they log in, when were they idle since, some CPU time, some other stuff I don't know what they're running. In this case, this is a desktop. This is a desktop screen. And then system information. This is the current time. Uptime 20 minutes. How long it's been running. I'm the only user logged on. And then load average is, I believe, 1 minute, 5 and 10 or something like that. I don't remember. And then the who command is kind of similar. It just gives less information by default. And then the checksum files. So if I do this and bin, so I think these are all checksums. So MD5, SHA1, SHA-2224, 256, 384, SHA normal, 512. I guess there's just a sum. What is sum? I do not know. So if I do SHA-256 sum on this text file I wrote, that is the SHA-256 hash of this file. And the other one is going to be different because it's a hash. So there's a bunch of these. Might not use them super often, but they're useful. The BC thing, it's calculator. Oh, it's not installed. Well, I can show you how to install stuff. apt-get install BC. And I guess it already had it downloaded. Cool. BC. It's calculator.
Oftentimes, it'll ask you when installing stuff to confirm it. If you don't want that, if you're installing a different programs and you don't want to have to say yes every time, you can always do the -y option, and that'll just answer that as yes for you.
Let's see if... Okay, that just did it. What's another one?
Apache too for Debian-based systems.
Oh, it's already installed. I'm trying to see if I can find... Trying one that's not installed. Okay, there we go. So I guess the other ones already were downloaded or something. So I guess it just didn't ask. So typically we'll get this prompt. And then if you do the flag, as he said, it'll just do it. And I'll just leave that as is. But yeah, I guess BC, it's a calculator. Really nothing special to it. I can do 10 to that. And yeah, it doesn't even show the top of the screen. So it's a calculator. You can do it very large numbers. It's nice. Factor.
How did you exit out of BC?
So you can do control. So I did Control D. Control D is end of file, which typically it closes the keyboard. So it's useful in stuff like Python. You can just do Control D instead of normally you'd have to do quit. So you see right here, use quit or Control D, i.e. end of file to exit. So instead of having to type quit every time, you just do Control D. I think for BC, halt also works. Quit works. I don't believe exit works. It does not. And then if you wanted, it has L. Yeah, it has a math library, so you can do cosine of 92654. It's about -1, which is what it's supposed to be. And if you actually want pi, it has the tangent function. Oh wait, what is it? Oh, it's atan. There we go. Which, if you do 4 times that gets you pi. You can do scale 200, which is decimal digits. And if I do this again, I now have pi to 200 digits. Fun little thing. And then factor, like I said, it just factors numbers. Oh yeah, and that thing I just did, Control R, reverse search. So if I start typing something, so earlier I I used the touch command to create the file test. And where is it? Touch. So it's here at line 67. And I'm all the way at line 166. So I'd have to go up 100 times to find that again. And I don't believe there's no other occurrence. So I can do Control R, touch, start typing touch, and it now finds the last time that occurred. And it found the last time, and I didn't have to hold the up arrow for. I don't have to hold it for that long. Oh, I should probably explain the last command. I think it was explained last time. The G in lowercase g goes to the front, capital goes to the end. Slash lets you search. So, and then hitting slash and just hitting enter repeats the last search. And then if I'm at the end of the file, it doesn't wrap. If you do question mark, it goes backwards. That's about all you'd need to know with less. The only other one I think I would show is this. So less typically wraps stuff, which is like sometimes alright, sometimes it's confusing, like here. And if you give it the capital S flag, it doesn't wrap and it does this little arrow on the side so you can scroll over and, read stuff properly. So yeah, that's that. Strings, bin, ping. Oops. It just does that, it's fine. Kill gives you the usage. Typically you just do kill and then some random process and it'll try and stop it. One other thing that I just thought of. So on the file permissions and capabilities, the ACL is that. Let's do stat bin ping. Okay, yeah. So normally ping, you might see this as RWS, the sticky bit. So it would run as root, but it's not. And I should be able to. I can run ping, but I'm not root. So if I do cap on bin ping, really weird. I actually don't remember what the format of that is. Name security.star. No. Weird. I thought that would work. Time to install it because I genuinely thought this would be on here. Okay, this is the capabilities thing. Capability list. It's got that many things. Some of the ones I said were kind of the equivalent to root would be, here we go, cap sysadmin. It basically gives all of these different permissions. It's kind of equivalent to root. So what's the simpler one? So this is the one ping normally has. Okay. Okay, so here's one. Actually, is there? Here we go. Okay, this one, cap F owner. Bypass permission checks on operations that normally require the file UID of the process to match the UID of the file. Basically, it's saying if the process or file has this, it ignores all permissions that normally check that you're the owner of the file. So like if Active Cyber creates a file and some other user, I don't know, bad user wants to delete it, they can't normally, but if they have this, somehow managed to get this capability, then they could delete it regardless. So, yeah. I think it's probably most everything that I could demo. I've kind of been rambling a little bit. Is there any questions or anything you like are curious about and want me to try? I can even do the like I said, I can go over some of the bandit over the wire stuff or help explain it, since you can Google the answers pretty easily.
Sure. I have just, I guess, a few questions. You don't really need to demo them. You can probably just answer them.
Okay.
So you said you're just going over like attributes or capabilities. Sorry. Ping, you said had like sort of had some pseudo-ish capabilities. Does like, I don't know, I guess file or stat have like some other type of capabilities like that? So like you said that file sort of reads into the first few lines of the file. If you don't have read permissions, you can still use file to, look into it, I guess. I don't know.
So that's just read permission. So let's see, if I get rid of the read permission on txt, oops, there you go. Writable regular file, no read permission. So as opposed to if I give read back, it says it's ASCII text. So like file just needs permission to read. On the contrary, stat needs execute, if I'm correct. Yep. So stat, you can see, I can see everything here, but I can't read the file. So then if I do that, I can read the file again, and then, oh wait, no, it doesn't have execute, never mind. Yeah, so stat, basically if you have access to the so the only time it won't work is if the directory you're in does not have the execute bit set, in which case you can't cd into it either. So yeah, I'd say stat works most of the time. So yeah.
Okay, yeah, no, I just want to. I was like, what? I didn't know that like commands could do that, so I was like, oh, okay, what type of other command? Like, what are other commands that are common that sort of do like things that you would think you wouldn't be able to because of permissions? But yeah, okay.
Yeah.
And then I guess two quick ones that you can just answer right off the top of your head. So for push D, pop D, and stuff, you can just do CD and then tilde and then do whatever number to like change quickly, change between the stack, sort of.
Yeah, you could. So
Okay.
if whoops.
And that would be just to keep track of like important directories that you want to, when you're pathing something or going through your code.
Yeah. So like if I got 3 on here, I could cd 1 and it's going to go to bin. Oops. So I'm at bin. I could go cd 3. Oops. 3, and I'd go to the home directory. Still there. cd2, and it's there. So yeah, it can be useful for either quick traversal or just simply to have a shorthand to reference a bunch of different directories without having to go cd / a user or like / bin, or if it's some really long path name, you don't have to keep typing that out.
Oh yeah, that's what I was like.
Yeah,
it's the quick way between the go between different, because usually I just use cd and then I use dash, and I only alternate between two, which is
Mhm.
pretty poor.
Yeah.
And then I guess my last question is just for cut. You can do multiple columns for it, so you're cutting and just I think showing one column, like either the
Oh
first
yeah,
or like the third.
yeah,
So you
you
can show
can.
multiple columns with that, right?
Yeah, I believe you can do like 1 through 4.
Oh,
Yeah,
okay. So that notation is just through. Okay, I got it. Okay.
yeah, it's just dash. There's probably a better way of like kind of dividing it.
That way you could choose like not continuous sets of columns. You could do like 1, 2, 5, 7 or something like that. But yeah. I was just wondering if it was like so yeah, okay, cool.
Yeah, you can do that.
Because then you can just output that to a file and then grep through it or something.
Yep, pretty much. You can even just grep the output raw. But
yeah, but the that works. I don't know. It's one is logs and one is
yeah.
when you're just going through it. I
So
guess.
on grep, you actually gave me an idea. So find has a neat little thing. So if I want to, let's see. Okay, so let's just keep it in my home directory for now. So it can do so it can do an executable thing, which, if I recall, this should be crap. Is it? That didn't work. Come on. I always forget. There it is. Find can execute a command and it'll pass the file it finds every time. Kind of show you this, that it does that. Normally, if I just do this, it prints the same exact thing. Just because it's a terminal. If I wanted to, I could say, do a little bash scripting here for file in this, the $ parentheses just says run a command. For that and that in the set, do echo file, done. That's a loop syntax is do command, and then I can just do more commands without a do every time, and done is the end. And then it does the exact same thing as the previous two. You can also do bash has like a shorthand enumeration. So you can do 1 through 10. You could do by twos. This is shell scripting stuff, but yeah. So I guess, is there any questions that people might have, like how would you do something? Because I've kind of just been saying, here's a command, here's what it does. Are there any things that people are running about, like how would you go about doing X, Y, or Z, and like what commands might you use for it? Because just to come up with something. Okay. Well, if I'm boring everyone to death enough, then it's almost 9. I think we can probably call it here. Again, unless anyone has any further questions or that sort of thing.
Just one last one, I guess, and since it's just more general. Do you have like any like saved up aliases that you really like to add to your like alias scripts?
Oops.
Or like just like a few?
So that's the default on here. Let me look at my.
Do you mean for Bash RC?
Yeah, for Bash RC or
So
anything that you think would be really useful. I mean,
I made a script some time ago, and somewhere on my computer here, I have a file that contains everything.
Yeah, can I paste that? I can't paste in the VM. Let me show you real quick. So you should be able to see like my main
Yep, we
terminal.
can see it.
Yep. So hopefully that didn't screw it up. So these are the ones that I just have on there. The LS ones I got just kind of grabbed from Ubuntu. for stuff. This -F just kind of gives you a type, like the type of a file. So if I just do L, this is my code folder. Stars are executables. Normal files are just not anything. Links have like an @ sign or something. That's just that.
I
Nice and
posted the one I use.
Yeah. This BC here is just, by default, I had it load the math library just because I don't have to remember this every time. And then because it can run a script and continue to drop into the interactive, I threw this similar to like a .bash RC. I threw a BCRC, which has like I just put a factorial function here if I want to use it. I have it calculate E for me, so I don't have to manually do it. Though I take that back. I think it actually by default computes it for you.
You got the Pythagorean theorem or quadratic formula?
No, I don't use it that much for that sort of thing.
One thing to note about it is a way to customize your terminal. Most of my stuff is just shortcuts, like LL for LS Tech, LAH, things like that. But if you do export, PS1 equals and then something, that's going to be the start of your terminal.
I've got it here.
There it is, yeah.
And then
I do tech W, which I think is the working directory, capital W.
It does.
What are yours?
So this one is user @ host and then working directory.
Okay.
Some people have a full path. The other thing I just wanted to show, and then I can let you do it. Tabs 4, because I guess set the tab size to 4. My history, I'm saying I want infinite history. I think I checked earlier. I think my history file is like 16,000 lines long or something.
I think I did 1 million for mine.
Yeah, and then I realized the other day, Python has a Python startup you can do. So I did this Python RC, which can have cool stuff in it. Just because I'm curious now. What is my history
you've
length?
done a lot more with it than mine.
Almost 19,000 commands. And that's not even how long I've had this computer, though it's probably close-ish. Not the same amount of characters.
Hey man, what can I say? I can double tap an O instead of reaching across to the slash.
Yeah. Okay. So I don't have the alias, but one that I've considered making, if you want to do this, is I would do it mkcd, and it would be a combination of make directory and then cding into that directory. Though I think that would have to be a function, just because of how aliases work. It just puts stuff at the beginning. You can't really have like arguments. That would be a function I would do, just so. Because I often am creating a directory and then seeding into it immediately after. So having kind of like a function that will do that for me would be a small efficiency improvement. But yeah, so if
that's cool. Thanks.
Yeah, you can customize your stuff to your heart's content. It's the beauty of it all. Well, if that is everything, then I think we can start wrapping things up. So, Richard,
You ready to shut down the stream?